Mohammed, it's been a pleasure to work with you. You're one of our most highly cited researchers, but in addition to the contribution you've made to your research discipline and to the students in your research groups, you've also made a major contribution to the faculty's service and leadership and to teaching generations of students. The number of people in the audience tonight is a testament to how fondly you're remembered by your former students and colleagues, and the number of your PhD students who are in the audience tonight is a testament to the major impact you've had on their careers and how fondly they actually remember you. Mohammed, thank you for all you've done for the faculty, for the department, for your research discipline, but most of all, thank you for all you've done for generations of students.
Well, Mohammed, I'm supposed to say something, thinking about you. One thing I really remember was when I first joined the university back in the mid-2000s, 2006 maybe, and you were giving your professorial inaugural lecture, and you showed this picture of yourself in the early days. And I remember to myself, wow, that picture looks like Starsky from Starsky and Hutch. So Mohammed, if you don't know who or what is Starsky and Hutch, Google it. Now you're retired, you'll have a lot of free time. Starsky and Hutch, it was a famous American TV show, and there was this really tough detective with the big hair and very 70s get up. So, but anyway, Mohammed, it's a joy to know you, and your inspiration, your research is outstanding, and I'm sure we'll still see you around as you're always an honorary academic in our department. All the best.
To everyone, I'm Gerard Rowe and I'm the Dean of Engineering, and it's both my pleasure and privilege to welcome you this evening to the Exaugural Lecture to be delivered by Professor Mohammed FARID. An Exaugural Lecture is an auspicious occasion for the university to acknowledge the career-wide accomplishments of a very long-serving member of the university's staff. It's also an opportunity for the retiring staff member to have a chance to reminisce on the impact of their work on the world around us. It's my pleasure to introduce Professor Mohammed FARID. Mohammed completed a Bachelor of Science in Chemical Engineering at the University of Baghdad in 1971, and he then moved to Wales, where he completed an MSc and then a PhD at the University of Swansea in 1972 and 1977 respectively. And he was a professor and head of department at the University of Basra from 1978 through to 1991, a professor at the Jordan University of Science and Technology from 91 to 1994, a professor and program chair at University Sains Malaysia from 1994 to 1997, and he joined the University of Auckland as a professor in chemical and materials engineering in 1997, where he's remained for almost 26 years. So, Mohammed, thank you for all you've done for your students, for your department, for the Faculty of Engineering, and for your research discipline, and we all look forward to your presentation this evening. Welcome, Mohammed.
Thank you, Gerard, for introducing me to my colleagues and my friends, my previous students, PhD students, and so many people. I'm so pleased to see you all attending. Thank you so much for being here. I will start my talk I made my talk into two sections. One about my journey until I reach New Zealand, and the other part is what I have succeeded being in New Zealand, being in University of Auckland. So that is the part one. Well, I am I was born in Basra, which is the south of Iraq. Baghdad is the capital. And Basra has been passing through beautiful time and through harsh time. I'll probably talk about that later. Now, I have put a picture of the hanging garden, which is not a real picture, it's an imagination of an artist, it's an artistic one. I deliberately selected this because there is always unknown how did they manage to bring the water right to the top with no knowledge of pumping and fluid mechanics and so on, which we study and which we learn and we teach. So it stayed, there are theory behind it, but nothing is really clear on that issue. So that's the reason why I selected what Nebuchadnezzar has built for his wife at that time. I also always fascinated with the marshes in south of Iraq. I have been a few times over there. It's a community which has been living thousands of years and in a floating homes and lives completely in isolation before, living on seafood, and they have cattle and so on, and it's fascinating and amazing. It is unfortunate during war Saddam Hussein has stopped the water resources to the area and damaged it, and the country has been trying to recreate it, and with some success on that. Well, I think you will never recognize this person. I always loved chemistry, football, and specifically photography. I used to have my dark room and develop photo, black and white, of course, at that time, and I still consider this as my main hobby still. I love it, but I haven't been practicing much nowadays. I put this picture deliberately to show you that my class this is the final class in the chemical engineering at Baghdad University, we were 50-50 female ratio to male ratio, and that was the late 60s, so it's fine. It's probably got a little bit confused nowadays, but that was the real story at that time. Well, I graduated in '71 from the department, got my degree, and got a scholarship to do my master and PhD. So I moved on following the graduation. I worked in a fertilizer company for a while, and then moved to Wales, to Swansea, where I did my master degree, and then went back for a short period, got married with my wife, Suhaila, and she joined me to Wales and supported me in my PhD work at that time. When I finished in 1977 my PhD, I managed to buy a car and decided to drive back to Baghdad. And my wife was pregnant, so I had to consult her GP, and he said, go, don't worry. You may have to learn some techniques in case it happened. Nothing has happened. It was a wonderful journey. We were only a little bit worried at that time, part of the journey, which is in Turkey. After you leave Istanbul and Ankara, then it becomes very remote. And you don't find hospital or anything, so, but nothing has happened. It was a wonderful journey. We visited many countries, and we spent about, I think, almost 1 month with very little money, indeed. We slept many times in the car. So I wish I could do that now. Well, I think you recognize me, the 70s, with long hair, me and my wife. Right. Right. So typical 70s, right? Yes, that was in London. Yeah. Right. So, what happened after that? I was appointed in the University of Auckland, and I acted for a period as Associate Dean, but the objective was to establish new chemical engineering department, because there was only one chemical engineering department in Baghdad. So I had taken that task, which was wonderful but tough, because Saddam Hussein has started a war in 1980 against Iran. And the University of Basra was almost near the border with Iran, so they can shell with any simple weapons the place. So it was a tough period, but I want to show the nice part and the sad part. So let me show you first the department which I have established at that location, completely from scratch, building, laboratories, everything, and had a staff, foreign staff and local staff, but mostly foreign staff, 8 professors from different places. And they lived a period of difficult time, a period of war. The nice thing is, before the war, we crossed to the university through the main river, where the Tigris and Euphrates join. You have Shatt al-Arab, which is, in the other side is Iran, and this side Iraq. And we crossed to the Iraqi side, of course, to the university through with our cars daily. Very enjoyable, sociable. We meet all our colleagues, chat, daily going and coming back. So I still remember that was an experience, and very enjoyable experience. Unfortunately, after 1 semester, and after building a full department with full facilities, it was smashed. We couldn't go to the location. We went in '88. I took this through my camera. It's not, at that time, there was no digital photography. It was, a normal video camera, so it's not very good resolution. And the department was damaged. We visited it only after 7 years, after the war ended. It was 8 years war, and it was damaged. Of course, when it was started severe shelling, we moved to another location. So I had to be involved in building another department in another location. So I became quite experienced in purchasing equipment, building facilities, building laboratories. I got that sort of, even when I came to New Zealand and some companies recognized me, in fact, company which manufacture laboratory equipment, like tech equipment and so on. They remembered, some of them they remembered. So we experienced a tough time in the war, 2 wars. And the second one was the Saddam invading Kuwait. And again, Basra is the critical place because it is near Kuwait. It was near Iran, and now it's near Kuwait. And we experienced 100 families in a campus, university campus, living in shelter, underground shelter. Was a nice memory of relationship, but frightening sometimes. One of the night where we had a big U.S. fighter hitting the shelter, but the shelter stand, I decided to take Suhaila and my 3 sons to go to Baghdad. I said, no way, we cannot continue. But how do we do that? I had only 20 liters of gasoline, and I thought, well, let me think as a chemical engineer. What can I do? Can I solve our problem, critical problem? It's quite interesting, but don't try it, please. We had many bottles of LPG, and in Iraq refinery, they were not purifying it well. So you have a lot of residue in the bottles, which you cannot use it for, for cooking and so on. So I managed to get a valve and took all the residue from, I think, 6 bottles, put it in my car. I didn't care if that's gonna damage the engine, with the gasoline in it, and it drove 600 kilometers, reached Baghdad under bridges, under broken bridges, under US fighters moving around and so on. So that was an experience of chemical engineering. Was useful, I think. Also, we had period of no water. We sometimes managed to get water, but of low quality. So managed to build some solar still based on solar energy, where you can have just a glass cover or plastic and water evaporate and condense. In some instances, we were worried that Saddam may use chemical weapons, and we had to think about carbon masks and so on, and as a department, so we got involved in these activities. Also, as a chemical engineering department, I think the department contribute into water desalination. We were donated by a company with big desalination unit which was not working, and the salinity of the water has gone up so high you cannot drink it. We managed to fix it, and one of my graduate students, she finished later her PhD at University of Auckland, and she's working in Sydney, in Melbourne. She ran that RO system, RO unit, and we were getting fresh water to the people in the area. So those are things which sometimes you feel you're pushed to work because it's so critical in life. I mean. Okay, so I think I will not be able to talk a lot about the period I have spent in Jordan, and because of the time limitation, because I want to talk about my activity in New Zealand. But it was a great period, 3 years in Jordan. That's the period where most of the Iraqi, 91, left Iraq because we were allowed to leave the country. And I think we have contributed to building strength in the universities in Jordan, not just me. I mean, all the big team from Iraq moving to Jordan. Following that, we have applied to the point system to immigrate to New Zealand, and we immigrated in 1994. I had at that time been accepted as a professor and program leader, postgraduate program leader at University Science Malaysia, and I had to go and come back until my wife said, no more, you have to come and stay with us. The boys are grown up and I need to be with them. So I quit and came and joined University of Auckland at the beginning as a part-time, and then continued my work until this day. So, in this part, which is the second part of my talk, I will not talk about my publication and H-index and so on. I really enjoyed so much working with colleagues, almost, I think, from all the department in the faculty. So I worked in collaboration with a number of people from the different department, in addition to, of course, my colleague in the department. I picked up this from the research output, and I cannot explain my enjoyment when I was supervising my PhD and master students. I mean, those students, some of them here, some spread all over the world, but I have and had so much feeling toward them. And yes, so it's definitely the case. I may get emotional if I keep talking about that issue, but I have collaborated with, as you see, with quite a number of staff. Some of them are here, and I am honored that I managed really to work with my colleagues in different areas, which is the food and the energy. I would like to take this opportunity to thank all of them, all my colleagues, all my students, the deans, previous deans, and Gerard here, previous head of department, including Ashvin here, for supporting me during these 25 years or 26 years. The technical staff, I have a lot of respect and acknowledge their support. Definitely, I would have not been able to progress without their support. So I hope I have not missed. I've took this from the internet, so there may be missing names, so I apologize for that. Right. So during the time I have been in New Zealand, I've been in the university, I worked into two areas, the food engineering and the energy. So in the food engineering, I have contributed in the theory and in the practice. In the theory, I have succeeded in developing a theory which can explain different processes not linked to each other with one model. And probably I can show you, so for example, this is a model which describes single droplet of spray dried of milk, 2 big pieces of meat, to freeze drying, all in single equation. And this comes, I think, from being away from, because I was never been a food scientist, I'm a chemical engineer, looking at things in a different angle. In the old days also, we managed to develop computational fluid dynamics to help the industry at that time when they introduced the pouches for sterilization of products and to predict where is the damage which could happen to vitamins and the bacteria, of course, in these pouches. Because it's complex, because that was 20 years ago, it was not well known because it was mostly cans. The industry is based on cans, not based on plastic pouches. So we have had some success in that. I was fortunate to be able to introduce the high pressure processing. Fonterra showed the interest at the same time. We were in parallel, and Plant and Food and my colleagues are here. We worked in this area. We managed to get funding for the high pressure processing. For those who doesn't know what is high pressure processing of food, this is instead of heating the food to kill the microorganism, you pressurize them to extreme high pressure and inactivate the bugs with minimal damage to the food quality. And after all these years, now we have in New Zealand, a few companies produce juices in the supermarket. You can find them treated by this technology. So we worked on Manuka honey also and shown that with high pressure processing, we can increase the bioactive compound in it through a PhD, of course, work. Also introduced and designed the first unit of pulsed electric field in the Southern Hemisphere. Food Science Australia followed that. So we led the area, and that is again another technology of non-thermal processing where you kill the bugs by extreme high voltage for very short time, in microseconds. I lost my timing. How is it? I'm okay? Good. Great. So we have worked on different variety of products in the pulse electric field, in extraction, and in microbial inactivation. Right, so we have a patent also on a technology which combine thermal and pressure to inactivate spores, where you can reduce the sterilization temperature and hence you get benefit of the quality of pumpable food. So this shows you that when you apply this technology, you can inactivate the microorganism much better than the thermal. So the thermal logarithmic reduction is much lower compared to the pressure-assisted reduction. So again, so most of my the focus in the food area was to really lower the thermal treatment for better quality. So that was the main work. So let me skip that one. I think this is something which was interesting. New Zealand has wanted to move from in the cooling of milk from the vat, the usual vat, to fast cooling of milk after milking and collection. And we were contributing to that. And we built a unit in Hamilton in one of the farmers where the milk was cooled in a heat exchanger using ice generated at night, reducing the cost, at the same time cooling the milk fast, retaining the quality. And the farmer at that time said that the grade of the milk has increased from B to A or A+, based on the technology. Unfortunately, we couldn't commercialize it because of some reasons. This is the system in Hamilton, in a farm in Hamilton. At the moment, it's not running, but it was running for quite a few months, for 1 year, I think. Right, so I moved to the other area, which is the energy. And I keep saying that we all know we have a problem in energy resources. We really need to find new sources of energy. But this is going to take time. I don't agree with some of the political point of view that we will be able, by 2030, to really develop new sources of energy. In New Zealand, of course, we are lucky in the sense we have hydro and geothermal, but we are going to struggle until really we find new sources of energy. Until we do that, we really should conserve the energy. And energy storage is definitely one of these. So if you can store solar energy during the day and use it at night, that's great. If you can store coolness in summer at night and use it during the day to prevent overheating and use less air conditioning, that is great. So that is my area of expertise even before I came to New Zealand. I was originally interested in the mathematical modeling of this heat storage system, but then we developed and patented UV encapsulation technology, because this material, they melt and solidify, they must be contained. So we managed to develop micro encapsulation using UV in a project funded by a Qatar Foundation on that. These are the microcapsules. So now the phase change material, when it melts, it doesn't come out. It's contained in these microcapsules. They are about 20 micron in size and so on. I skipped that. We, with the help of Winston Wallboard 20 years ago, built facilities. It was at Tamaki campus, and then it is moved, the whole building, which I will show you in a minute. I'm showing you now the difference between the old days and recent days. In the old days, you have thick walls. I have been in some, not in this building, but in some of these old buildings, it's comfortable even when the weather is very hot, because it has a storage. So it stores the coolness at night in the bricks, but we can't do that anymore. This is what we have in our building. So we need to do something to store the energy, because we cannot afford doing that. So the facilities, at the moment, they are at Ardmore Airport. They are remotely controlled. We can do many things in them, and quite a number of PhD students graduated based on these facilities. They equipped with solar radiation measurements, temperature, everything, and transmitted to the department the data, so we don't have to go. They were at the Tamaki campus. When the university sold Tamaki campus, they've been shifted to an area near Ardmore Airport, and they are still running there. You have 2 of these offices. One has the phase change material, and one doesn't have, and we have been testing them and see the benefit over almost 18 years to see what is the benefit which we can get. There is heating, air conditioning in them, and just a quick demonstration of what happened in summer and winter. So if you look at summer, you see, for example, the purple line is the room which has no phase change material. The black is the one, the temperature is damped, so the temperature doesn't go high because the material absorbs the heat, retain it, and at night release back the heat, and that minimize the air conditioning. And in winter also, you can see that the solar radiation which comes through the window is captured by the material, melted, but it doesn't come out, of course. And then in the evening, it releases the heat, so your heater will not start early. It will be delayed. Energy saving, forget about the graphs. You can see you can save energy of the order of 32, 15, 60, depending on the days and solar radiation. But you can save extra money, not energy, by switching your heating, in this case winter, heating, during the low peak electricity. So when the cost, so this is a result of one of the PhD students. He did very smart control in the system. So when the temperature goes down, the heaters start. But at the same time, when the price of the electricity goes up, switch off the heating and so on. So you have this double control to sustain comfort. And you can create extra saving, which is saving in money, in addition to the energy. So this has been ongoing and we had to prove the concept elsewhere, because this is for Auckland. So we started doing computer simulation of, if we use this phase change material in the walls of building at different cities all over the world, what will happen? And amazingly, I mean, you have 1.5 gigajoule in Auckland of energy saving during a year, annual saving. You have 1.4 in Brisbane. You get no saving in Singapore because of no temperature fluctuation and summer and winter. You are near the equator. You have significant saving in Madrid and San Francisco. Amazingly, in a city like Bogota, we were surprised to see huge saving. And I thought it's something wrong. We have done something, a mistake. Until really I visited that area, not Bogota itself, but nearby there, and realized what is it. It is on the equator, so it's similar to Kuala Lumpur and say Singapore. It is near the equator, but it is very elevated, 3,000, the elevation, 3,000 meter, and this is why the temperature fluctuation was in support of the phase change material melting, solidifying, and create benefit. Then more work has been done using solar energy, solar air heater in these huts, and one of the PhD students is there. She's done work on building a heat exchanger for storage and showing sort of benefit. The daily energy saving can go sometimes to 80% or close to 100%. Work has been going on. we did not leave an important area, which is the cold chain. And we have looked at the possibility of, with the building, you need material which has a melting point around 20 degrees, which is the comfort level. For cold store, for chilling, you need something like 4 or 5 degrees melting point. So we did some work, and what you see is a performance of a fridge with and without phase change material. And what happened when you switch off the power of the fridge, or you open the door and leave the door open, the temperature escalates, and when you don't have phase change material, within 1 hour, the temperature becomes high enough to damage the food. When you put phase change material, you extend that period significantly. We are at the moment looking at potential commercialization in this area to see if this can be applied to refrigerated trucks, and because of the same principle. The interesting work of one of the PhD students, he did on ice cream using phase change material, and what you see here is ice cream stored 14 days in a situation which is not well controlled, in a freezer, of course. And then you see the distribution of the ice crystal. So the ice cream loses its smoothness, and I think some of you must have experienced that. It becomes more crystalline, it's not anymore acceptable, and you can see the crystal size grown up, became very big, while when we applied phase change material, this time the phase change material has a melting point of minus 16 degrees Celsius for freezing application. And the crystal size distribution remain intact, the same for 14 days, even under the frequent door opening and so on. So it can be useful. We have tried it to cool lithium-ion battery, and we had success in that application. We worked in a fundamental project, and then one of my previous students established a company in Chicago. He produced battery cooled with lithium, with PCM, with phase change material. He sold, I think, the company. We then more recently in the years started working on thermochemical energy storage. I will not go in details in this area because of the time limitation. So the phase change material, you have material, when you give it heat, it melts and store the heat. And when it solidifies, give you back the heat. The thermochemical energy storage has a better, higher energy density. So if you have a reaction and you give heat to the reaction goes forward. If you bring it back, you will get the energy which you have stored. And we have some collaboration with a big organization in the US. They have interest in utilizing our expertise, and the last PhD students here, Ruby, has worked in this area. And it's basically, it may look simple. It's if you take any salt with 6H2O, you give it heat, the water will go out, and you get anhydrous salt. If you bring moisture to it, it will react, generate heat, give you back the heat which you have wasted. I think it has great potential on waste heat, and hopefully there are some technical problems to be solved, which I think I will probably stop. Am I all right with the time?
Oh, you're fine for time.
Great, great.
Mohammed, these are the keys to your Mercedes-Benz. You might need it for another trip from London to Baghdad.
I wish I could do that.
Thank you, Mohammed.
Do you need that or? You can need that.
Do I need the mic or is that? Okay.
Okay.
Oh, you have time. Yeah. Thank you for that very nice talk. I learned something new today. So you went to Bogota because you're questioning the data.
No, I was invited to a conference.
So that's how we get to no.
But I realized then the why was that. So I had the answer to that.
Yes. And you didn't want to talk about citations and H-index, but it's I'm glad you talked about the research because I should share with people that Mohammed is one of the highest cited engineers in the world, and in New Zealand, and that he's applied himself to fundamental research and so cited here for the uninitiated. Cited here when we write our papers that nobody reads. Cited means someone has read it. That means someone's interested in your stuff. Somehow you've managed to excite interest from from people out there on your very, it's very highly technical, highly scientific work, and people have picked it up and used it and referenced it in their research, and it goes on. So you create a whole series of people building up on that work. And as we can see, the number of PhD students that you have supervised, and every day I'm working in my office and I hear this laughter in the kitchen. And it's Mohammed talking to his PhD students and they enjoying his company. Not all the time in the kitchen. And I think that's another aspect that we will surely remember fondly, even as staff members. We used to sit in the 12th floor meeting room, discussing about things.
Right.
And Mohammed always gives this unique perspective. Today we can see from his history where he's a unique human individual who has had a unique experience, and thank you for sharing that. That I thought was very insightful for me to hear about. I guess not just the struggle, but how you coped with it, how you ingeniously found solutions for you and your family, and I think it's an inspiration for us. From history we learn. As you have spent the 25 years here, you have graduated as a colleague, a well-loved colleague in a department. Probably when you first came as a brother, then eventually as a father figure, and then now as a grandfather figure. Right. And you got your grandchildren here as well. So I think in your retirement, we look forward to that new phase, we know you'll keep in touch and stay with us.
Thank you.
Yeah.
Thank you.
Just as a token of our appreciation, this is a card where people have written little notes for you to express fondness for you and a tribute to you, and also a little gift from the department. So thank you, Mohammed.
Thank you.